Hi, this is Ed Marzell, President and CEO of Kenexis, and today I'd like to give you a little tour of the Vertigo application for safety instrumented system design basis. Vertigo is one of the modules in the Kenexis Instrumented Safeguard Suite, and this tutorial is kind of a getting started tutorial to provide an example of running a SIL verification calculation in the Vertigo framework. So if we're going to perform a calculation, and in this case we're going to perform a calculation of one of the safety functions in the General Oil and Gas Operating Company Chemical City plant. Those of you who've taken some Kenexis training courses will probably recognize the facility and company that we have created specifically for purposes of performing training classes, and there is a training course packet where we provide a lot of information about the facility, including a process flow diagram and some P&IDs. With respect to this tutorial, we're going to be looking at one specific safety instrumented function. In this case, what we're worried about is V101, the high pressure separator, and there is a pressure measurement where if the pressure goes high, we're going to want to close the inlet valve to protect the vessel from being overpressured and rupturing. And we have assigned a target of SIL1 to this. That was done separately through a layer of protection analysis. We're not going to get into the layer of protection analysis details at this time. We just know that we have a safety function and that we want to run calculations verifying that the coverage target has been achieved. So if I go back into Kenexis Instrumented Safeguard Suite, right now you'll probably notice that I am in the Project Manager section of the database, where I have a list of facilities that I have access to or I own, and the studies associated with that facility. Well, in this case, there is no General Oil and Gas Company Chemical City facility, so I'm going to need to create one. So I do that by looking at the action ribbon and going into the Facility Manager. And when I click on the Facility Manager, it gives me a list of facilities that I can edit, or in this case I'm going to add a new facility. And the facility name, I'm going to call it GOGO, General Oil and Gas Operating Company Chemical City Plant. And I could put in more information, but I don't need to. Things like the area could be Gulf Coast, and the segment could be chemicals, and the region could be something like North America. And I can insert things like SIS life cycle plans and so on. In this case, I'm not going to enter any more of that information. I'm simply going to insert, and you'll see there is GOGO Chemical City with myself being the owner and no other authorized users. If I wanted to give other people access to this facility, I could authorize them to have access, but I don't need to do that for what we're working on now. So I'm going to go back into the action ribbon and go back to the study list of the project manager, and now you see GOGO Chemical City. I select that in the facility list, and you'll see that there are no studies. Since I just created the facility, that would make sense. So I'm going to need to add a new one, and I do that by clicking on the Add Study button in the action ribbon. And the type of study that I want to create is a Vertigo study, which is an SIS design basis, as opposed to an FGS design basis, fire and gas. That would be for effigy. So I click on SIS design basis, and it begins the process of creating a new facility. So I'm sorry, not a new facility, but a new study. So for this study name, I'm going to call it the Chemical City Gas Plant. And the project ID would be a project number if there was one that was necessary. I'll just put in 123.456 and go ahead and create the study. When I create the study, it brings me into the SIS Design Basis Overview page, which you can always get back to this page by clicking on the Overview button in the Action ribbon of Vertigo. And I could put a little bit more information in here. Specifically, I can put an asset owner in, so General Oil and Gas Company, and go ahead and update that. Now, right now you'll see that on this page there is nothing here in the chart, which this area would have given you a pie chart indicating the number of functions of different safety integrity levels. We haven't put any in yet, so nothing shows up here. Now, the meat of the application is the IPF list, which of course at this point in time is going to be completely empty. But before we start putting in information about the instrumented protective functions, we're probably going to want to put in some baseline study data. And the study data is available by clicking on the study data icon in the action ribbon, which will bring up the study data page. On the study data page, you have basically listings of the instruments that are part of your study, the instrument types that are part of your study. So under instrument types, you can think of this as the library of different types of instruments that are available for use inside this specific study. We'll come back to these as we build instruments. And then the next thing we're going to have, which is where we're going to start, is a list of drawings and a list of IPF groups. So for drawings, what I'm going to do is I'm going to go ahead and I'm going to click Add New Record, and then I'm going to type in a drawing number. So what I want to do here is I want to make a list of the drawings from which I'm getting data that I'm putting into this study. So if I go ahead and I look for the drawing information for these PNIDs, I can see that my drawing number is DXXX.XXX-02, sheet 2 of 6, it's revision 1, and the drawing title is High Pressure Separator. So if I go back into Effigy, I can say that it is DXXX.XXX-01, sheet 2 of 6, and it is revision number 1. And then I could put in a description such as high pressure separator. And then I also have the ability to put in a hyperlink. So let's say you have a web-enabled data management system where you keep all of your PNIDs. This process gives you the ability to have hyperlinks where you can simply click on the hyperlink and bring up the appropriate drawing as you're working with the facility. So I don't have anything available for this particular drawing, so let me just type in the Kenexis website for demonstration purposes, and I can click OK. And now you'll see I have a record of this particular drawing that includes a hyperlink, which if I click on it will bring up the web page. So that's something that's available for your use, and it makes the process of putting together your facility easier. Now, IPF groups are basically a method for grouping instrumented protective functions that are all related together. Generally, when you create an IPF group, it's going to be based on a major piece of equipment. We're going to want to assign instruments and safety instrumented functions to IPF groups to help in the sorting and classification of those groups and facilitate specification development and facilitate the development of cause and effect diagrams. So I'm going to go ahead and add a new record here and create an IPF group. I'm going to use standard ISA naming conventions. So a safety function is a UZC, which means it is U multivariable, Z for safety instrumented system, C for controller. So UZC, and I'm going to call it, actually I'm going to call it 101 to make the name consistent with the vessel, and put in a description of this IPF group being associated with the high pressure separator V101 using our standard naming conventions. And I'm going to select OK there. So now I've defined my IPF group that I'm going to associate this function with. Okay, now that I've done that, let me go back to the IPF list and start putting together our IPF. So if you remember, the safety function that we're defining is high pressure at the separator closes the inlet valve. So when I go back into Vertigo, I'm going to create a new record to define my first safety instrumented function. I'll give it an item number. Let's say it's item 1. I will give it a tag name, UZC -101, and then this is the first safety function in that IPF group, so I'll call it UZC101A with the description in the standard Kenexis naming for safety instrumented functions. We start out with the major piece of equipment being protected, that is the high pressure separator, and then in parentheses the tag number of the vessel or piece of equipment, then the deviation that is being measured, which is going to be high pressure, and then the action that is taken, which is closes inlet valve. Of course, leaving out the instrumentation tags from this description. Okay, the IPF type is going to be safety instrumented function, but you have a range of different IPF types that you have available for sorting and nomenclature purposes, and we said that we were going to assign SIL 1 at this point in time. The other items that you're going to define here include the IPF group voting logic, which most of the time for both inputs and outputs is going to be 1 out of 1, meaning that we have one measurement group. An example of a place where you'd have multiple measurement groups are, for instance, if you were measuring the runaway reaction in a reactor vessel, and you could detect that with using both temperature and pressure, and perhaps the temperature is 2 out of 3 voting and the pressure is 2 out of 3 voting. What we mean by group voting is how do you vote the groups themselves, the temperature and the pressure. Does the temperature and pressure both need to be high to indicate that a hazardous condition exists? That would be X out of X. Or if either the temperature or pressure goes high, that indicates a hazardous condition. That would be 1 out of X voting. But in this case, we're only going to have one measurement and one output action, so they'll both be 1 out of 1. And then if we wanted to put in some notes, there is a field for entering notes about the safety instrumented function. And let's go ahead and click OK to insert that record into the database. Now you'll see that we've entered the record in the database, and then for sensors and final elements, right now it says no records to display, and what that means is that we haven't assigned any sensor instruments or final element instruments to this safety instrumented function. Alright, and a little bit more information here. You'll see the expand button. And what the expand button is going to allow us to do is drill down and get a lot more detail about the safety instrumented function. So there's a summary page, there are details related to the safety requirement specifications for this function. There are sensors, logic solvers, and final elements that are associated with this safety function, and then there is a tab where we can input revision information. Now you'll notice that for sensors, logic solvers, and final elements, we have the ability to select sensors that are associated with this function out of our database simply by clicking Add New Record. Well, in this case, when we try to select something, you can't select anything because no instruments have been defined. So now we need to go back into our study data to define some instruments. So I go to the action ribbon and I select study data, which is going to bring up the study data page, and now I need to define instruments. And in this case, let's start out by saying I want to define pressure transmitter 101D. Well, when I go into Vertigo, I can start creating a function, but before then, I need to know more about the instrument types. So you'll see that there's a database of instruments and then a database of instrument types. Well, an instrument is a specific instance of an instrument type. So PT101D is a specific pressure transmitter, but the instrument types allow you to define generic types, and the generic type is going to hold information about failure rates. So the starting point for a lot of what we're going to do is to build up the database of instrument types. So I can go ahead and I can do things like define process connections, sensor interfaces, sensors, logic solvers, final element interfaces, and final elements. And I can either define them on the fly by clicking Add Custom Component, which when I click Add Custom Component, I would have to enter in the information about failure rates and safe failure fraction. Or I can select them from a library. So when I click on Add from Library, I get a drop-down box which would allow me to select items out of the database. And the database that you select from is going to be a function of what your study settings are. So I have my study set up to pull information out of the Kenexis standard database, but your company can build their own database that you can use for performing these calculations. So I'm just going to stick with the Kenexis standard database. So I'm going to go ahead and insert some instrumentation into my project database from the library. I'm going to start with process connections, and out of the generic library, or the Kenexis standard library, I'm going to pick a generic impulse line and insert. And when I do that, you'll see that the device gets loaded into the database, and you can see information coming from the database. So in this case, a failure rate of 5E-6 with 0% safe, meaning that full lambda is dangerous undetected. And I'm also going to put in a sensor interface. So I'm going to add from library. And in the library we have a generic intrinsic safety barrier, which I will go ahead and insert, and that brings the information into my database. For a sensor, add from library. In this case, the only sensor that I'm going to need is a pressure transmitter, so I will go ahead and select a pressure transmitter generic high trip, meaning that the function is for the transmitter to indicate a trip condition as the pressure increases. And I'll go ahead and insert that into the database. Then for a logic solver, I'm going to pick again out of the library. I'm just going to go ahead and select a generic SIL certified PLC. And for final element interface, if we go back to our study, bear with me, as you'll remember, we're showing a ball valve. So I'm just going to go ahead and pick a generic air-operated ball valve and a generic three-way solenoid valve as the final element interface. So if I go back here, for final element interface, I'm going to add from the library, and I'm going to select a generic three-way solenoid valve. And for final element, I'm going to select the air actuated ball valve. So now I've loaded several instrument types into my database. Now I can instantiate specific devices. So I'm going to go ahead and click on instruments, and I'm going to add a new record for a sensor. So with the sensor, I'm going to start out with the calculation information. There are 2 pages. There's calculation information and then there is details information. Calculation is the information about how the device is being used so that you can perform a PFD and a mean time to fail spurious calculation. And then the details page contains safety requirement specification information for that specific device. So on the calculations page, I'm going to go ahead and say that this is PT 101D, and the service description would be high pressure separator is the location where the device is being used. In terms of voting, I just have a single device, so that's a 1 out of 1 vote, but I can select a full range of voting types. The test interval, let's just say we're going to test it once every 3 years or 36 months. Then I need to select the different components of that sensor subsystem. So I'm going to start out by selecting the device itself, which is a generic pressure transmitter. I'm going to select the process connection of impulse line generic and select the interface type of intrinsic safety barrier. So you have the ability of not only selecting the device, but also a process connection and up to 2 different sensor interfaces. And I am also going to now look at the table that talks about how the device is used. So what factors do we want to include in the calculation? By default, we always include common cause failures, and we also always set the functionality so that there is a trip when a failure is detected with that particular component. In this case, it's a 1 out of 1 voting arrangement, so there's no need to run a common cause calculation. Let's say we're going to configure the safety function such that if the transmitter self-diagnoses a failure, it will set the function to the trip state, causing a essentially a spurious activation. So I will leave that there. And if trip upon detection is checked, then inputting the diagnostic test interval is not of that great of importance. And then we also have checkbox for online testing, and if we do online testing, we would need to put in a duration of that test. And then we have a checkbox for imperfect testing. So if I wanted to say that the testing of my device is imperfect, I would put a test coverage and a useful life of the component, or a mission time of the component here, but I'm just going to say we have perfect testing. So the only parameter that I really need to mess around with is the mean time to repair, and I'm going to just go ahead and leave that at our 72-hour default number. Now I can insert here, and when I perform that insert, now I can again use the expand button to look at the details, and you'll see that a calculation for this component has been run. So you have the overall subsystem failure rates, which is going to be a summation of the failure rates for the device itself and also the process connection and any interface devices. And then the PFD calculations are performed, including the PFD contributions of items such as common cause, dangerous detected, online testing contribution, and imperfect testing contribution, which in this case are all zeroed out because of the selections that we made. We also have the spurious trip rate contributions, which then result in an overall PFD and an overall spurious trip rate in hours. Now on the detail page, we're not showing anything. Let me go ahead and edit this so I can show you a little bit more about the details. For the details, we'll be able to do things like select that this is a high trip. We could put in an actual trip setting. Let's say 750 is our trip setting. Let's say our range was from 500 to 900 PSIG. And we might have a trip setting tolerance of 2 PSI. a response time of 300 milliseconds. Input type is analog input. Data reference would be the P&ID upon which this function or this instrument resides. So I'll go ahead and select that P&ID, which is the one that we input. And then I will also select an IPF group to which we are going to assign this instrument, which is going to help us down the road when we're doing our SRS and specifically our cause and effect diagrams. We also have spaces for datasheet references. If there's a startup override or a timer, we could define it there. If there is a tag such as HS PT 101D, which might be a DCS point that's used for bypassing of that of that device, we will want to define what the action on failure is. So we can do something like de-energize to trip or trip. And we could put in also some information related to the safety manual. And finally, there's a checkbox as to whether or not this device is safety critical, and we will check yes that it is. When we hit update, now we've entered in some of the SRS information for that instrument, and we can use that information when we're generating our reports in the reporting section for the safety requirement specs. So I've defined a sensor. Let me go ahead and also define a logic solver. So I'll add a new record and just call this the safety PLC. Give it a test interval again of 36 months. And I'm going to say it's a generic SIL3 certified PLC. If I had a description, I would say safety PLC for gas unit or something to that effect. Simply click insert, and now the device is defined. And again, we've included our PFD and STR numbers have been calculated at this point in time. And we can also go into a little bit more detail with regards to SRS information that would be associated with the logic solver. Similarly, we can also define a final element. For our purposes here, let me go back, and this is going to be SDV 101. So SDV 101 is the tag name, and the description would be high pressure separator inlet. Give that a tag number. And the voting would be 1 out of 1. It's a single device. We're going to test it 36 months again. And for an interface device, I'm sorry, the device itself is an air actuated ball valve, and our interface device is a 3-way generic SOV. And then we can put in the same information about online testing, imperfect testing. In this case, whether or not we put any information in about trip on detected failure is not going to be relevant. I'm going to say no, we're not going to trip on a detected failure, because you can't really do that for a valve unless you're doing some variety of partial stroke testing, which allows you to bring the plant down to a safe state. Generally, we don't trip upon diagnosed failure of a valve, because unless you're doing partial stroke testing, which in this case we are not, whether you check the box or not doesn't really matter from a calculation perspective, because there will be nothing in the dangerous detected failure category. But just to make it look correct, we will say no, we're not going to trip on detected failure, and no, we are not going to include common cause, because it is a 1 out of 1 device. And for meantime to repair, we'll just go ahead and leave that 72 hours. We're going to assume perfect testing, and that the testing is all done offline, and click insert. Okay, after I run my calculations, again, you'll see that the PFD calculation and the spurious trip rate calculations have been completed. So now I've defined all of the instruments one at a time, and you're going to want to go ahead and define your instruments on the instrument page to a good degree as a precursor to doing a lot of your work. But at this point in time, For this study, I've defined all the instruments that are going to be used in the study. So now I need to go back to the IPF list, and I'm going to actually insert those devices. So for this safety instrumented function, high pressure closing the inlet valve, I'm going to go onto the sensor page and I'm going to add a new record and say that I am going to use PT101D as a sensor. I'll go ahead and click insert, and when I do, it brings all of the information for that pressure transmitter into the database for the safety instrument function. Similarly, I will go ahead and assign the safety PLC. And in this case, if you have multiple safety PLCs, let's say that you have a safety function where a vibration measurement is going to a compressor monitoring PLC, and then the compressor monitoring PLC sends a signal to your safety PLC, you can do that in Vertigo by defining multiple logic solvers. In this case, I've only got the one safety PLC, and then now I'm going to go to Final Elements, add a new record, and I'll be able to select that shutdown valve and insert that. So now that I've defined everything, you're going to see that now on the SIF list, you'll see that the pressure transmitter and the shutdown valve are now listed. If you had multiple sensor groups, let's say a pressure transmitter, a temperature transmitter, flame scanner, whatever, a long series of sensors or a long series of final elements, those would all be separately listed in the IPF list here. When I click on the expand button, now all the calculations are refreshed and we can see a lot more information. So let me go back to those sensors, logic solver, and final element pages. So what you see down on this row for the pressure transmitter is for PT101D, what is the PFD and STR. Then in this area here, you'll basically see the summation or the product, depending on whether you use 1 out of X or X out of X voting, of all of the devices. Since you only have one device, the sensor overall and PT101s are going to be the same. But if you had multiple measurements, they wouldn't be. And you'll see that is consistently done for the sensor, for the logic solver, and the final element. I should also note that you'll see the fault tolerance that's achieved by the different subsystems, along with the max SIL that's approved with respect to architectural constraints. And then finally, if I go back to summary, now we have our final summary calculations. And in this case, we did not achieve our SIL1 target. You'll see that we only have a risk reduction factor of 9, so the achieved SIL not applicable. The overall PFD average is greater than 10%. Max SIL approved for use is not applicable. Has the fault tolerance been achieved? No, it has not. And what is the overall mean time to fail safe? In this case, it is 7.9 years with a dangerous detected failure rate of 2.43 times 10 to the minus 5 per hour. So something we could do at this point in time is we can edit this if we were generating a report, and we could put in information about functional test interval would be 3 years. This isn't used for calculation purposes, it's only used for reporting. Analyst comments would be things like the failure rate, the probability of failure is too high to achieve the SIL target. SIL target. Consider decreasing the test interval, and then test type would be full functional test, and then perhaps you might have some general notes that you would add in there. So when you update that, additional documentation shows up on this page for you to provide more information. So that's how you enter information in. It's a good starting point. If you want to do reporting, we can do various kinds of reporting for here. Let's say we just wanted to do a SIL verification report. And in this case, there's only one safety function. So I can select the one safety function. If I had multiple safety functions, I could pick the ones that I want to show. I could do filtering. A lot of reporting tools are available for you here. You first select the type of report that you want, and let's say I just want SIL verification details, and then I click export, and it's going to generate that report for me. So here is an example of a SIL verification report. If you wanted to use that report as part of a study, you can export it in a variety of different formats, ranging from PDF files, CSV files, Excel, rich text format. There's a variety of ways you can import this information so that you can insert it into the documents that you're using for your reporting mechanism. Okay, and with that, that is a quick introduction, getting started with the Kenexis Vertigo application, the SIL verification or SIS design basis application inside the Kenexis Instrumented Safeguard Suite. This getting started tutorial barely scratches the surface of the functionality that's available in the toolkit. In order to get a better understanding of the full range of capabilities of the software, I would recommend taking the Kenexis Using Vertigo online training class, which provides a lot more detail on how to use all of the features of the software application. Thank you for your time.